definitely like
This, which is fine. This is just like the index.
Yeah, this is fine.
That's it. And so this is going to be the only this is of relevance. And in this case, so there's nothing of value in this page.
Yeah.
This is like when we look at another page that might have some.
I don't know, like 20, 30, and that's a lot of those.
上周来，现在你不是来几天？
crazy.
Nice, AI%.
It's entirely possible.
Is that good? Is that correct? Let me get you your
This one has.
They are so expensive too.
Looks like a tape.
Does the clicker?
But using a more expensive LLM, it's already embedded into a model file, and that's I haven't picked up on that. Looks pretty good.
Nice to just.
And my super qualified, like the most CS guy ever. Mine too, I have like white films and then like black
Test?
text.
Yeah, I mean, I am like this.
Oh, okay.
Yeah,
So
I think it is fine. Internally, that would be best.
and Mike is also on.
We are not leveraging the expertise we already have.
Okay.
The thing is, to do that, it takes time. And
Oh, I have many. Hopefully not hack type of questions. That's my goal.
you could export from like,
Absolutely. Oh yeah.
I don't know. What do you think?
Only if someone can do it like
After
basis. Fine, I think I have a starting point to do crappy.
Your first
Like how I'm really deep into CS.
It will not be foolproof, but it will be.
Actually,
It's
I have to imagine myself. My thinking is they have not generate the slides, and they have some OCR like thing that like converts some of it into text, because now you can export. Now you can export RPS.
Last night I applied for a Google Gemini credits for research grant. Not even been 12 hours. I don't think they're giving me credits
Like
for
PhD math straight from now.
This plot is like taken from a plot and then it's like it's reproduced a lot of it, but it's converted. So this is actually combined from multiple plots. These lines are from one plot. This line is from another one. Yes, I can show you the original. Like the original slides where I checked it up. This is actually it's the plots.
I've seen that
to make this.
the free open source.
Yeah. So this is all like
Really generous free trial.
I don't think we're at that level
it's
of
everything here
characterizing it. It's still like in an earlier stage.
with like very minor editing.
You know, it doesn't always.
This is what I told it to type on this blog, and then it just did this. And I'm like, that's not what I intended. But it's so funny. And this is supposed to be clock code. That's it. And then it does this.
Oh, okay. When we get to the point where
That's what I'm saying. Like, I'll show you. It's like generate a whole like slide by slide.
半导体到安检，再到实习，然后飞机上的乘务员。那每一天只有4个航点，就是这边 check in 嘛，必须在安检台碰到部分的人，在那个登机门右手同样的给你一个办托运的人，然后在飞机上的那个乘务员还是给你办托运的。
tell me what, give me a question.
I feel a little scared.
I'm not surprised.
I think if you're doing
The sad thing is,
It's a really high level. Yeah.
like this slide definitely exists, and that's
So, like the fact that
from China.
yeah, because like this title of the talk is like not
That are from
involved in
Western
the slides.
companies that also
My slides
close.
are talk title,
So-
and it kept my name, it kept my affiliation.
NASA.
I guess that's
Yeah.
fantastic.
You cannot run
really starts this NASA system, the US government system talking about NASA as a federal agency. Just giving people the strength to interacting with the community. So if we adjust and I would not be surprised if they just start with
Wow.
You're enough.
Upgrades.
Big time. Falling apart. It looks like these chairs, honestly.
I guess you have the trading behind them, by the way. Maybe Gemma is really good.
Yeah, exactly. It's like
Gemma is intentionally handicapped.
there's this, like whatever they
Good enough.
Yeah.
Or very
I don't know what the hell they did.
The ones by Alan.
in the tutorial
They're not state of the art.
they were talking about having
That is,
a source name to what that, so I'm probably going to add that.
government has its
Efficient way of doing that.
How are you?
Yeah, so I have that. Yeah, I have
They're still from the same.
landscape.
Yeah.
I can just, we have
I'm local, so.
have to manually write and like what.
My last name is a unique.
I don't have that many of them, but I just have.
Almost in all of them. Rhymes with Chewbacca.
I'm using the DSMO.
You can age out your
Very nice.
They probably only see it written down.
Are you using? Yeah, it's GB2. It's very cool.
All right, welcome back. The break. First talk of this session, an invited talk by Joshua Spiegel. So if you're ready, go for it.
Okay, can everyone hear me, hopefully? All right, so I know this is not the title that's in the agenda, so I apologize. I originally was supposed to talk about trying to design sort of like a podcast that you could use to keep up with the archive. If you are curious about that, you can come talk to me afterwards. It's called Aperture. It is available on GitHub. It's a little finicky, but it works. R is in the archive, so it's misspelled. It's misspelled, just so you know for the Googling. After seeing the agenda for some of the talks and some conversations I'd had, I asked permission and got and was granted or at least I was forgiven for completely changing the talk. So I instead wanted to talk a little bit, because I feel like this is very appropriate for the meeting, about what I would call like AI for scientists, sort of learning and doing in the era of VLMs. And what I mean by this, I just want to say, is that I think we're designing a lot of tools and infrastructure. I mean, there's a lot of talks about all sorts of things that are being built, and all sorts of ways in which they can be used, right? We're learning about RAG, we have agent systems, we have a lot of sort of different searches. We're going to hear more things, in this session. We heard them in the morning about all the ways in which these can be used. And so I want to focus on that aspect here, since I think there's a lot of parallels with software and with how science actually gets accomplished. So I thought that would be good. One small Easter egg I'll note, by the way. So again, I could be wrong here, but I think this is the only talk that was generated with Notebook LM. So if you notice the watermark on the bottom, this whole talk was generated with Notebook LM, so using AI. So if you want to ask me how that happened, let me know, because I kept it because I thought it was very funny. Or at least it's much better than I thought. Okay, so the main thing here is just to start off with something, which is that most people, like we are here in this room because we understand and are interested in the impact of AI and how to build tools, right? We are the people who really are the ones actually trying to engage with this technology, or who want to, or are stakeholders in sort of people engaging with this technology. But in a lot of cases, this is true in general, most users are not going to be experts in this technology. So you're providing them, when you build tools and you adopt policies, sort of a service or a framework or a harness, as some people might say, in order to engage or interact with this technology. And in many cases, right, this is happening well beyond what we should expect most users to know. And I want to start by going back and talk about sort of general statistics and software adoption, because I think this is useful. And I do have a separate talk, if you're interested in the numbers that you'll see in a second, about this in astronomy. But the idea is that when you don't understand how a statistical software works, the idea is that sort of this piece of software has this kind of statistical modeling expertise. And so if you call a package, say like MC, which I'll talk about in a second, you might not understand how it works, but you know, like I do this thing and it gives me the error bar, right? Like I put in my model, I run it for a while, it looks okay. Maybe I don't know exactly how it works or exactly what okay means, but I know it gives me that error bar and that corner plot, that's what I want. This is very different when you now are saying, well, I want someone to do an analysis, to ask a question, to answer a question for me, or I'm doing a search that I don't really understand. You know, if I'm searching, say, semantically, for example, you know, you can explain RAG to people, but that's a very different type of query than, say, one where you're just searching keywords. So there's some fuzziness that starts to come in, and so this level of expertise sort of increases. And now if you have issues with your outputs, you sort of require an increasingly broad set of expertise to diagnose them. And this can be a good thing or a bad thing, depending on how you're building or thinking about these tools. So I want to start with MCMC. For people who don't know, it's Markov chain Monte Carlo, because I think it's a really good example of how all these things come together. So these stats are real. I got them from ADS. Thank you. And I have other queries if you're interested about this for nested sampling or for machine learning in general. But essentially from the early 2000s to now, the amount of publications that use some version of MCMC has grown about 200-fold. This has actually grown in lockstep with the publications that use Bayesian, always some fraction of them usually. And so this is much larger, obviously, than the growth of publications in the field. So people have adopted MCMC as a sort of workhorse of doing inference very quickly, and it's now very popular. And why this happened is entirely driven by accessible software. So this wasn't like some magic thing. If you look at sort of exactly when adoption kicked off, it essentially kicked off about 1 or 2 years after the publication of MC the Package by Dan Farimaki. And currently today, about 44% of all papers that mention MCMC mention the package EMC. And I think for reasons that I won't go into here, this essentially means that almost 100% of papers that do MCMC analysis use this package. It's not exactly 100, but it's like a humongous vast majority. And a lot of times, the reason that number is about 44% is because papers that cite MCMC don't often use it. They're often either taking results that have been derived from it from other papers. And so this is actually, I think, pretty much a saturation point. This process took about 10 years for this to happen. So there are other plots I could show. But the main reason why people use this package is because it was easy, right? Like that's it. Like is designed to be really, really easy for the end user. This code, which again, all generated by AI, I didn't type this, is that you don't really have to have any tuning. You can set it up in 5 lines, and it will like just run and give you the answer. Like that's it. And this is great. Like the point is, you can say but there are all these failure modes, all these other things, but the fact that this made it accessible to the end user, to the average astronomer who no longer has to learn what MCMC means to apply and use it in their data is really the heart of what has led this revolution. This has been even stronger when it comes to things like machine learning. So I don't have the plot here, but if you look at the same plots essentially after the publication of scikit-learn, you see that this giant rocket ship of papers that start to use all sorts of machine learning methods. And by the way, at least as of 2024, the amount of papers that use the term machine learning or deep learning actually outnumbers the number of papers that use the term Bayesian. So we are now a field of machine learning AI. So this is great, but of course, like this doesn't actually mean that people learn what this is, right? So if you look at the data, only about 25% of papers discuss anything related to burn-in, related to MCMC. If you don't know what this is, that's okay. Or warm-up or any other diagnostic that says, am I converged? Only 7% use anything related to either proper convergence diagnostics or sampling diagnostics. These are terms like mixing, R-hat, Gelman-Rubin, thinning, like anything related to just, have I checked that I have a good effective sample size? Only about 7% of those papers use them, and this does not change as MCMCs become more popular. So as you've seen this 200-fold increase in usage, the fraction of papers that cite this has not changed. So this is the point, right? Like 93% of papers have this uncertain reliability in the sense that they don't cite the metrics necessary to reproduce results or confirm that the results are robust. If I had to give a number for how often I think this is a problem, I'd say probably anywhere from 10% to 30% probably have what I would call vibe errors, and that they haven't really checked that the error bars are correct, and this probably affects the results in a qualitative but not quantitative way. If you're curious, there's some additional papers that have checked whether, for example, you have priors that are even correct, and it turns out that a significant fraction of papers don't. So they're sampling from a distribution which is unconstrained. We can get to this later, but the main point is that you see this huge growth in users and people actually like adopting this technology. You see almost no change in people actually becoming experts at this. And so when you're designing any sort of tool in this conference, we talk about all these things here. We love to know the details, but you always have to think the end user is not only not going to need to know the details or want to learn the details, but is going to interact with your system not knowing these details. So you always have to keep this in mind. Andrew Gelman has a really nice quote for this. He likes to say that statistics is the science of defaults. And this is a good thing because it means that if you provide a really good default to people, you can then accelerate and improve all of the downstream things that they do. So that's, I think, really the idea that I want to impress is that when we're thinking about software and designing these things, we always want to think about what is that default setting that this is going to enable people to start with. You know, usable software creates broad adoption, and also if the defaults are well specified and thoughtful, that is also going to lead to safe outcomes. So that's the idea, right? You don't want to force people to have to learn, like get a whole degree in statistics before they can run an analysis. You don't want to force people to learn all about the details of detailed balance and ergodicity and all these things related to MCMC in order to use a package to solve a problem. And you don't want people to have to learn how all AI models are trained and do reinforcement learning and before they can use these agentic systems or understand RAG or anything else that we've talked about in these meetings. So this type of behavior is really useful because it enables this type of abstraction. And you can imagine, and I think we also worry about how that level of abstraction could potentially, if it happens too quickly, how that can detract from potentially or create dangerous outcomes if there are important details that you need to actually specify before that. So again, that's the idea, right? Is that you always should be thinking about the fact that non-experts are going to be the target audience most time for the tool, the people using the tool, and so you need to design the tool, the defaults and everything around that type of stuff if you want to see software become really usable, really friendly, and adopted very broadly, and also to get the outcomes that you want. You can sort of live in the world where you say, but people should learn these things, versus the fact that we all know that when we go home, we're tired. And so we're not going to do that all the time. And we're the people who like learning, right? Like we're the crazy ones who are like, I love feeling dumb all the time. Isn't it great, guys? Like if we don't want to do it, definitely the average person's not going to want to do it. And that's okay. That's actually great. So this is my point, is that if we think about AI, it's going to follow the same thing, right? We already see that the fact that, what changed was the ease of use of these systems, right? About you can put them in the terminal, you can put them on your computer, right? At home, online, and the fact that you can talk to it easily, that you can access it easily, it has low latency, all these sort of things have lowered the barrier to entry. But the failure modes are different now, right? In terms of how the types of risks and errors that these occur. And this is not like extinction risk type stuff. Like it's just bread and butter, like things, right? So for example, again, going back to statistical software that we are used to, a lot of times you say, well, what can go wrong if you don't do the analysis correctly? And it's just, oh, you're shifted a bit, right? You have these errors. You can look at a couple diagnostic plots. Things are fine. If you're now saying, like, I have some agent system or I'm running some complicated query, the type of error you get changes, right? This is the type of error that we are used to dealing with in other contexts, but we're not used to dealing with when it comes to software. That is essentially the fact that we have a stochastic decision process. If you delegate a task to a human, you sort of know at some level that they're going to make a bunch of choices. They're going to decide how they want to look at the data, how they may want to process certain things, make certain decisions. You might hope that they write these down, but we are very bad about doing this. We're even bad about remembering the decisions we made and why we made them. And when asked, we'll just make up facts to defend the fact that we did something. We have to now take this same attitude and be like, this is now what's happening with software as we get the same problem. If you ask it to execute some task, you can get this very complex stochastic process that gives these varied outputs. The outputs can be opaque. The models also are known to do the same things that we do, and that they don't know their own internal decision process. And so if you ask them to explain, they will do the same stuff that we do, and often will come up with some reasonable explanation that may or may not be true. And so in this case, you have to now say, well, what happens when I have sort of agents or these types of things now operating in this setting? Like, I have to design potentially controls or at least frameworks for dealing with this new type of error. I can't just go and check it by sort of monitoring something, and I have to say, okay, if I need to delegate a task, maybe that task is low stakes, and so I don't care if there's some stochasticity, as long as I can sort of check what happened and maybe I can get a report. But if it's higher stakes, you can think that the verifiability here is not that you can get exact reproducibility, but that you can sort of span the probabilistic space of possible solutions if you handed this to a team of analysts, right? So you might say, I need to run this 10 times. And every time I'm going to get some slightly different results. And what I care about is the envelope of results that comes from an analysis. And how many times am I willing to do that to sort of check that the range of outcomes is acceptable? 10, 20, 50? Like, these all have costs now associated with them. Maybe you say, that's great, GPU goes burr, I can run it 50 times. But, like, this is my point. It's like, yes, you can run in parallel, just like with statistical modeling, but it's just very different end goals you have to think about. So if you're thinking about designing agents or even these other things, just something to keep in mind. One thing I'll also point out is that it's also good to think about, like, should you even be using these things at all? There's a wonderful set of results in education, which I could talk a lot more about. So this is a recent study from Anthropic, from Shannon Tamkin, that tried to do sort of this. They did a randomized control trial with software developers, where they got them to learn a very strange package, and essentially had some of them use AI and then some of them not use AI. And what's amazing is that you see this great set of multifaceted results, where essentially for the people who used AI in general, after they did a quiz afterwards, they did about 20% worse. But they thought that they were learning and they thought that they were more productive. But actually the time that they spent was the same. And the answer to this, which we are actually aware of, is that lots of these people discount the time that you spend prompting the model from your own mental accounting. And this was about 30%. And so it turns out that we do the same thing. We feel we're more productive when we talk to the model because we don't count the time that we take typing our own response to the model as part of our own sense of how long we talk to it and how productive it is. This explains a lot of results about why people feel that they're being more productive with these things, but also surprised by how long it takes to do something. So again, this is kind of a very interesting psychological thing, but the point is, sometimes you don't need AI to do it. Like, you can be just as productive not using it, and you will learn better. So sometimes it's fine. You can just leave it out, right? There's no point in like delegating tasks if actually it's not useful. Again, like, I think this goes back to, in some working group we've talked about, like, there's a conversation around sort of at what point do you call this task delegation versus something like skill acquisition. And you want to encourage fluency, but if you sort of over-encourage these things or design systems in a way, again, thinking of defaults for software use, how you think it's going to be used in a typical workflow, even in the way that you desire, right? If everything works out as you want, This can discourage developing the critical judgment skills you need often to monitor these systems in the first place. And we as humans have a wonderful capacity to treat tools as an extension of ourselves and also develop parasocial and relationships with them where we trust them more than we should. And this is already shown to be true with AI systems. And so if you have any system that is good, which is what you want, people will trust your system more than they should. And you always have to design around this fact that people are going to use it in ways that's not intended because they think it can do everything. And so one question is, when you're thinking about how you design defaults, you might actually make your tool slightly more difficult to use if you're like, this is actually really important, because if people don't do this, then like there's a problem. So again, think about like, what is that default setting that people are going to be using your software and these things to do? One way that you can, at least I would just say to think about this, this is education focused. There's this wonderful framework called backwards design. People also think of this as goal setting. But the idea is that rather than say, like, here's what I want, you instead say, well, like, what is the outcome that I want to come from this? Like, what is the objective of the software? What am I doing with this type of thing? And then after that, you need to determine, like, what would be acceptable evidence. Like, if I am designing a tool like, let's say, Pathfinder, you know, that I want people to use to do all these things, like, what would, to me, then, when I put this tool and deploy it in the wild, would I think of as, like, being a big success? And if that's people come up to you at conferences and tell you that, like, oh my God, this is the best, then that's great. Like, that's exactly what we want, and Kartik, you're the best. But like, there are many other things where you might have to think really hard about, like, what does this mean for, you know, how, like, can I even define this? And if not, you then need to think really carefully about whether you're doing the right thing if you have no way of determining whether you're successful or not at your task. So this is a good way to think a lot about wanting to iterate between these first two things before you even go out and say, okay, well, now here's my tool, right? Your tool might have to change if you need to actually change what you want it to do. As with most things, I always joke that, you know, people are like, I wish we had John Woo, and I say, well, I'm John Woo at home. So John had a blog post about this a while ago, actually, and the idea is that you want to treat these things a lot as like sort of the showrunners or trellis, which I had to look up, sort of this scaffolding in which things grow within, right? You want to have some sort of backbone, and the idea is that these AI systems then can fill in lots of these areas, but you want to be very careful about how you do that. I also will note that I asked the model, because I had the link, to please cite John Woo's blog post, and that's what it did, which I thought was I thought was very funny, so I kept it in. But he does have a blog post on this, which I think is nice and links to the original source material. I think a good example of this actually happening now is for anyone who's used Claude Code or Codex or these other tools, you can tell very much that like the way in which these things are being built is very much with this in mind, right? That they're designing systems for these models to operate within, that these systems matter a lot. Like for people who've tried out different services, you can see just how big of a deal like this matters. The underlying models are the same, and yet some people are like, oh my God, Copilot is so bad, or like, oh, Codex is weird, or I like this style, I like this. And it's all this scaffolding around how the models interact, right? And they're all being built very deliberately with a lot of these things in mind. So I like to say that you get to see this in action, and you can use this as a good framework to say, how do I want my software to fit into this? So to close, I'll sort of say, like, just think about like these questions. You know, what does it look like if you're thinking about the end user when designing a product for these sort of like VLMs? Are you starting from a science goal or a capability? Those are very different sort of end goals that you're trying to target towards. And your software might need to change, or at least the role it plays in your framework might have to change. And especially like if you think about what happens if this tool is being adopted in the way that I want, does it sort of create a situation where it undermines like its own usage because you need to have some sort of critical evaluation? I think this is more of a question for orgs, but it could also be a question if you really care about, you know, using a tool to build fluency, for example. That would be very different from a tool that's designed to be used to delegate certain tasks. So I'll close with this, which is just, I think it's good to remember that every tool here is going to be used by scientists. And I want to leave lots of time for questions, and that's it.
Right, thanks a lot for this amazing talk. First question, Eric.
Yeah, this wonderful talk. I really like your analogy between statistical inference software and AI, and I'm going to poke at that a little bit more. A person who, I'm intentionally leaving nameless, but a person who is an eminent developer of statistical inference software, not Dan Foreman-Mackey, just to be clear, once told me they stopped developing statistical inference software because of exactly this thing you're talking about, right? They basically said, too many people are misusing my tool. I made it easy, and now they don't think about it, so I'm not going to do this anymore. Do you think that's a rational response from the AI perspective as well, or do you think this is taking something too far?
I'd say it depends a lot on what you want to happen. I think that if you reframe it as that this is inevitable to any tool you build, then you have sort of two options. You either have to say, well, I have to really design tools with this in mind if I want them to be widely adopted, or you can say, I don't want them to be widely adopted because I only want them to be used in this very responsible way. That's a very fair position to take. It just means that you say, like, look, I'm designing something for experts. I know it's not going to be used by a lot of people because I want to ensure it's used properly. I think for AI tools, it's the same. There's definitely a range of things that you can build, and as long as you know what that target audience is, it should be okay. But if your goal is something like, I really want this to help a lot of people, you have to also deal with the consequences that a lot of people are going to use your tool without sort of that safeguard that you want them to have.
Please.
This is a somewhat related question. Like your example with Dan Foreman-Mackey and MC. I mean,
it's a lovely example and it's a lovely package. Yeah.
Yeah, and so one underlying assumption is that an expert built that tool, right? And
yes.
What's different now, right?
Yes.
In AI land is that things can be built by non-experts.
Yes.
And so how does this change how we think about how people use our tools, how things are trusted?
That's a great question. So I think another way of putting that is that in the past, the sort of expertise necessary to build such a tool required you to be an expert, and that no longer is the case, right? And so the fact that a tool is easy to use or does a thing is starting to become decoupled with sort of the trust that you place in the development of that tool. I don't have a good answer to this because I don't think there is one. I think this is sort of to get very broad, I think this is much more of a decoupling of expertise and trust that we see in a lot of places. You know, in terms of the news, in terms of organizations, like because of lots of these similar phenomena, not related to AI, but the same underlying tension. So I don't have an easy answer for what to do here. I think it's just going to make people much more hesitant to use these types of things in the future if they're not sure where they came from. Or it might place more of a premium on having to build up your own brand as a developer. I don't know the correct answer here.
Thanks, Josh. Yeah, this is fantastic. I kind of want to go in the meta, of statistics and thinking about, people who your audience or, for the tools for whom you're building stuff. It's not just a person or one type of person, but there's a distribution of people, right?
Yes.
And just as, I know that you did very meticulous work on, homogenizing the star-forming main sequence, with tons of meta studies and so on. And for that, I know that you're capable of doing, careful work, which is why then when you throw a completely, AI generated slide deck on here, I'm still like, okay, Josh, I thought
it turned out okay. It was pretty.
I thought it did not turn out okay. It wasn't good.
Good. Okay, good. We had one person. Yes.
No, but it's interesting. But I trust that you reviewed it. You're not just sort of slopifying, this
yes.
work up.
Yes.
And but there's a distribution of people out there, and the vast majority of stuff that I see, I don't know if I can make that assumption that that they are capable of doing this very, very detailed inspection of what they're putting out there. So what is so maybe that last bit you just said as well, what are the signals by which you mark yourself up or somehow what do you how do we respond to this as a community?
I don't know. I mean, I think in some sense this has been true for a while. It becomes true, I think, as the information density and especially things like paper density continues to increase, and your ability to sort of track what's going on sort of becomes harder in some sense. I mean, that's one reason I was originally talking about this tool I used to turn the archive into a podcast was because I can't follow all the ML literature. It's 300 papers a day. So I'm I can't read these. I think it just becomes a lot more difficult, and you end up having to put in some sense, I think, again, with the analogy with sort of news and social media, you get this retreat into really tending to over-rely and put a lot of trust in individuals instead of in systems or general things. Like you sort of lose a lot of trust in sort of lots of mechanisms for regulating stuff. Maybe the answer is that we have to introduce a lot of like new tools to help improve that. Like maybe, you know, in the future, I'm not saying we should do this, like there's going to be some like auto reviewer that will provide comments on archive papers. And then there's going to be models that like, you know, every time you submit AppJ, it'll like run an AI model that tries to do reproducibility of your paper. And if it fails, it'll be like, yo, I couldn't reproduce your result from the paper. And then you're like gated from publishing until the editor like intervenes or something. Or they have like an automatic check for language, or they do like, you know, citation checks. Like maybe all of this stuff, like using these AI tools will help by creating that, creating that scaffolding for trust. So maybe there is a way in which we can build that back and deal with this. But I would say I don't have a solid answer right now. So I think it's, I think we're all figuring it out.
Yeah, I think we have time for one more question. I think Ashish was first.
I had a somewhat related question. Your AI flashed some percentages. Were those hallucinated? And if not, what do they mean?
So which percentages for the particular MCMC one, right?
5%, 93%.
So those are right because they're taken, most of those are pretty close because they were taken from a talk I gave with real data, which was part of the training for this slide deck. Some of the plots are a little bit fuzzy because they've been replicated from the real plots, which I can show you. But the general numbers are broadly correct, yes.
And what do they mean, actually? Those numbers sound something.
Which numbers? The
7%, 93%. How would you interpret them?
So I would just interpret this as when you see a paper that's published that says that they use MCMC, only about like maybe 3/4 know that with the tool, an important part of using it is you have to check that it's actually gotten to the right answer. So the vast majority of the field does not either think that this is like something to even mention or check for. So I think that just shows the level of overall expertise. And among the group that even knows what to check for, only a small amount actually do the quantitative check to make sure that it's actually correct. So most of them just do the visual inspection to make sure things look okay on a plot, which is usually what's reported. So I would say that if you then say for people who use this tool, a very small minority of them actually are doing quantitative checks to make sure that the results are accurate, which I think speaks a lot to how people use these AI tools as well. There's a very small amount of people who actually would go through and do due diligence on the outputs. I think, so you're putting a lot of trust in the tool itself. Some of that's misplaced because the tool can be misused. Some of that is probably okay. So like of that subset who at least talk about burn-in, I think probably the results are fine. But the subset that don't talk about this at all is sort of where I would be concerned, right? Hopefully that provides some more context. Yeah.
Right. Let's thank Josh again. And next up is Nolan. Give us a minute, please, for setting stuff up.
Okay, sounds good. Thanks so much. Perfect, thanks. All right, hi everybody. I'm Nolan. I'm a PhD student at the University of Toronto. And today I'm going to be showing you work that I did at Polymathic, which is an AI for science group in New York. And specifically, I'm going to be showing you how we used language models to build a search engine for galaxy images. And so out of 20 million images, you can search stuff like merging galaxies with tidal tails. Or you could search edge-on galaxies with dust lanes. And these are real results out of 20 million unlabeled images. And the idea is that here you can search for anything that you might want to describe in text. So if you're particularly interested in an edge-on galaxy with dust lanes, then typically what you would do with supervised models is you would have to collect 10,000, and then you would have to label which ones are edge-on galaxies with dust lanes, which ones are not, and then train a neural network, and then run it over 20 million. But now you can just try out this search engine and try, searching it just of text. And it should be general for what it's able to find. But I'm going to go into, how we made it, its faults, stuff like this. So the general idea that allowed us to enable this capability is that we found out that GPT could write fairly good descriptions of galaxy images. You could see this example one here. It says a peculiar, irregular merging galaxy system with dual luminous nuclei and tidal features. And, we made a benchmark for this. We didn't just trust it off the bat that it was, good quality descriptions. We actually made a benchmark and compared it to Galaxy Zoo answers. And we found that about 50% of the answers from Galaxy Zoo volunteers matched the descriptions from GPT 4.1 Mini. And the idea is that if you can then generate descriptions from the images, you can build a search engine. And so we did this with 300,000 images randomly chosen from Legacy Survey and HSC. And then we generated 300,000 descriptions. And from that, you could just Control F, and try and find what galaxy you're looking for. But if we want to do this for 100 million images, not just 300,000, it's going to cost $50,000, which we didn't, want to spend on generating descriptions. And so what we did was we used the 300,000 descriptions that we generated, and we used contrastive learning to build a model that allows us to search images with text. And so what contrastive learning does is you take an image, you turn it into an embedding, which is just a vector that describes the image. And in this case, we're using Aeon, which is a foundation model that Polymathic developed. And it turns it into an embedding. And the whole goal is to line up the embedding, which should describe the phenomena in the image, with the embedding that should describe the meaning of the text in this latent space. So with contrastive learning, you're basically training like a small MLP to basically just line up the images and the text in this space. And so we do this for all the 300,000 images. And what it ends up producing is it produces, this space where the images and the text are aligned that you can then use on all your 100 million unlabeled images. You can project it into this space. And in that space, you can, the images are accessible from text. So you can then project a text query into that space and then find the nearest images. So you're just doing cosine similarity between your text query and then the closest images around it. And the ones that should come up are the ones that should that match your query, theoretically. And so, like as an initial investigation, you could take, and this is a real result. So you can take images of spiral galaxies, mergers, galaxies of streams, and gravitational lenses. Put them in this space, and then you can put the text queries in that space as well. And they should lie in a similar region to the actual images corresponding to that text. And you'll see like tidal streams, we just selected these images randomly. But tidal streams, the text lies on top of like the actual galaxies of tidal streams, which I'm going to show you I actually use later. But you can kind of see, okay, it seems to be working. But to actually get a metric for how good this search engine works, we used a benchmark where we're kind of asking, okay, if we search visible spiral arms of text, let's look at the top 10 images that come up. How many of them actually have visible spiral arms according to the fraction of Galaxy Zoo volunteers who voted that they had visible spiral arms? And we can compare this to image similarity search, which is another way to search these data sets without training anything. You can just, if you have a way to embed an image, you can find the most similar images. And what you'll see is like, okay, the image query here is, there is spiral arms, but it retrieves images that are similar, most similar to the query, that's obvious, but they don't necessarily actually have spiral arms. It could be like a ring. So the Galaxy Zoo volunteers didn't say it had spiral arms. Where when you search for it, you can be direct that you want exactly this phenomena. You don't want just a similar image. You want all galaxies that have this phenomena that you're searching for. And so there's an advantage there. And when we actually develop a metric, so this was used for like document retrieval for reg, this NDCG. But you can just think of it as like 0 means that it retrieves no spiral galaxies. 1 means that in the top 10, like all of them are spiral galaxies. And you can see that, compared to image similarity, we're actually able to do quite well. And so I made this an app that you can actually use. It's public, and it's free. So you can search 20 million images currently. It's been used over 1,000 times, mainly for public outreach purposes. And you can type anything you want. So, and I've been able to actually use it to find galaxies with streams. So we found about 40 here. And just through searching with text. And so I'm ending it off by saying that, these models can now take in images, and you can prompt them to be classifiers. And so I'm making a bit of a claim to, put everyone's mind in the right place, that in summary, you could think of these language models that have been trained on all the papers and all the NASA, astronomy picture of a day, and have been trained on all the Galaxy Zoo discussion forums. You can think of them as astronomy foundation models that you can then use as your first step for for classification purposes. And so I'm really excited to see where this leads. Thank you very much.
Nolan, that's a very cool tool. And I see there are already a couple of questions. I'm not sure who was first. Maybe you.
Great talk.
Thanks.
You said that an LLM could be an astronomy foundation model now. Do you see a future for astronomy-specific foundation models, or do you think LLMs are going to get in that space?
That's a great question. So the strong advantage I see of using language models as vision astronomy foundation models is that you don't need to fine-tune it. You can just prompt it with text. And so if you have a scenario where you're looking for a rare type of galaxy that you don't even have 1,000 examples to then fine-tune Zubot, for example, then you might have to use this language model. But if you have 10,000 examples, then fine-tuning Zubot is almost definitely going to be the language model, depending on the task. So absolutely, there's still a use case. Yeah.
Thank you, Nolan. I've seen your work, and I've asked you this question before, but so how much physics do you think this model can recover? So if you're going to prompt it with something that is not a morphological feature, but a quantity on which you could regress, say, star formation rate, do you think this would be able to do it? The representations that you create, both before you align them, separately and then together. That's the question.
So it's a great question. And I think that, I have a theory that if the language models could add any information to already the image embedding that you might predict redshift from, or you might predict star formation rate from, the language models have a unique ability where they've been trained on the text. And so they might be able to understand the context in which an image was taken. They might be able to understand, oh, there's actually an artifact in this image, and this has been described in some paper somewhere. And that might be additional information that could help when predicting like redshift or star formation. But this is a very interesting experiment, and it's really hard to say where that would go. So I think that's worth exploring. Yeah. Thanks.
I prompted this with 0.1 0.1 solar masses per year versus 1,000 solar masses per year, and I mean, you could see something that makes sense. But fully regress, that's a different question.
Yeah, it's super cool. Great, thanks. Cool.
Right.
Thank you.
Let's thank Nolan again.
Thanks.
And next up is Roman. Ah, there you are.
There you are. Sweet. Alright, do I need to press something?
No, that is for your pocket.
Oh, right. Sweet. All right, hey guys. So my name is Roman and I'm from University of Bern in Switzerland. And this is the work that I did with Sandor of the European Space Agency, where we are trying to, train the models to generate the ADQL queries and query the Gaia data. So I guess as everyone around here is using LLMs nowadays, you're also using it for coding, where paradoxically, most of the software engineering they're saying is going to be obsolete in a couple of years. I'm not so sure, but this is what they're saying at least. So one of their applications is the SQL generation. Like big models are super good at this, and now the smaller and smaller models are being developed more and more basically to be more open to the public and not have giants like OpenAI that are basically, like a monopoly. So one of the SQL dialects is ADQL, which is coming from SQL 92, and more specifically, it's using a bit like specific functions that are not found anywhere, like this circle or point that you can see here. So models that haven't seen this beforehand are incapable actually of generating such queries. So ChatGPT has seen the data that includes ADQL, but you're not sure which models have seen it because these models are closed ones, right? So they don't show you what data they use, they don't show you what weights they use. So that's one of the reasons why I decided to use the open source models, or open models at least in terms of weight, which you can find on the Hugging Face. One of the works, it was already done by the way by Nolan. Hey there. So where he uses already ChatGPT to generate the ADQL queries, and it works quite well. What he utilizes is, the long context window of such models. But this, of course, degrades the inference time because, the longer your inference, the longer your context window is, the more it takes to compute. If you take it externally on clusters that are hosting, ChatGPT is not a problem. If you're hosting such models locally, it's impossible. Sweet. So let me just quickly touch the training of such models. So we have multiple phases in training large language models, including pre-training and post-training. That's how I would separate it. In pre-training, you're basically trying to train your distribution of the data. So if I give you a sentence, my name is, what do you expect next words to be is name, right? So you try to increase the probability of such words occurring. Afterwards, you do alignment and reinforcement learning. And at the total end, you can do fine-tuning. Because what is the reason why we do fine-tuning and why I'm mentioning, for example, the parameter efficient fine-tuning methods is that when you employ your model locally, let's say 7 billion parameter model, it's impossible to train this model because it takes a huge amount of compute to train this model. So people use some tricks to basically decrease the parameter space that is trainable so that, let's say the memory that you're using to compute the training decreases, right? So that you can train it on one GPU, let's say. One such transformation is simply, decomposing the matrix. So here is like a, hidden layer that you're trying to, predict. This is the weight matrix that you're trying to train, and X is a vector of inputs, let's say. The goal here is basically to train this W, the weight matrix. The way the people now do it is they decompose the weight matrix into two other matrices, and by that they can control the rank of both of the matrices. Basically by this they reduce the trainable space. So I'm using this method basically to train the model on the ADQL queries. So here is some methodology. I will go quickly through the inference, training of the models, and finally the regs, where I don't want to spend that much time because I think nowadays everyone spends a lot of time here on the regs. So at the start, I received 25 gigabytes of raw user ADQL queries from the cluster that were executed. Now what is needed to do is to decode it, parse it through some parsers to check if it's synthetically correct, and finally replace literals or variables with variables. You can see it here. Basically, we take every variable that can be defined and replace it with, some like a standardized variables so that we can group the queries so that we don't get, let's say, 1,000 queries of the same variable with different variable, basically. This leaves us with like approximately 20,000 samples. Sweet. So now I mentioned that we have the ADQL queries, right? But we also need the natural description, which would actually the user enter to generate the query, right? So for this, we actually need to use the LLM to generate the queries, right? What query would lead, for example, to this, what prompt would lead to this query, for instance, right? So we utilize the LLM to generate this alongside with other, information. And this is how the, one of the examples looks like. So here we have, the query that is coming through, and here is the question, that is generated by the model. Then we use the model finally to basically train on the question and the prompt, the question and the query, right? So these are like, this is your training pairs. This is just like some quick images so that you get idea, for example, about the length of the queries, right? What is the distribution in terms of their length? As you can see, most of them are, below 400 in terms of the length. Sweet. So how do we measure the performance? There are several metrics, including blue. I don't want to go that much deep into this. Let's think about it as accuracy, for instance. Parsability, so if it's the query is synthetically correct, and the relevant results. So if you run your query through the API, will the results be the same and correct, basically? And finally, the loss. So before I go into the training in the next slide, I want to just quickly mention the regs and the long context inference. As you can see here, there is like a similarity, blue. So I basically take the prompt, right? I use the model to generate a prediction using, some information coming from the regs, either being tables, columns, or I can even give it like, gold standard. So what tables and stuff goes through. And then I get the similarity values, right? So as you can see, the similarity is not that high, right? Because we would want probably close to 1. And the baseline is 0.4, so the regs are not, providing much in this regard. This is what I mentioned before, because the models are not, used to these specific keywords that are coming from the ADQL. So here is like some training results that you can quickly see. So this is like a loss curve. So what we expect on the train loss, of course, is to decrease over the time. And the evaluation loss, which is like, the split that we are not training on. And you can see also that we're achieving low loss. This is to us not that much. I don't want to go much into detail. I want to go into the evaluations now. So when we now look in the similarity for the baselines for multiple models, we can see that we increase, let's say, like twofold the similarity in this way. But of course, here we cannot say that similarity is the perfect measure, right? Because it's not telling you anything about the query itself. It's not telling you, is it executable? Like SQL queries, you can write it infinitely many times just by renaming some columns, for instance, right? So one additional option is, of course, to use, as I mentioned, like the APIs, right, to query the database and get some results. So here you can see the blue, you can see like the parsability, so it again improved, like let's say twofold. But as you can see, the matches are quite low, right? Even after fine-tuning, like 30%, like a column match, for instance. The problem here is that the model doesn't hallucinate per se, but just by renaming or like having a prompt that doesn't specify what to name the column as, the model can name it, as I mentioned, infinitely many times. So, your exact match is not gonna be correct. Right, and I think I'm out of the time. Right, these are just examples. Yeah, and then the conclusion is like, with the fine-tuning, we can achieve quite a good results if spend more time with it. We of course need a bit more data, and we need custom benchmarks to evaluate these models properly. Of course, if you have any questions, I think it's better for you to ask than for me just to talk, because my mouth is completely dry. Thanks a lot.
Thanks a lot, Roman. And I think we have time for one quick question. Yes, go ahead.
Do you have any thoughts about expanding your data set? Like, is there any data sources you haven't tapped yet that you could tap?
But yeah, go ahead.
Yeah, I think that Sandor is going to give me more raw queries. But the easiest example I could imagine is that if your query is very complex and long, you could basically decompose it into multiple stages of difficulty, right? So if you have select in the query, this could be one very simple. Then another clausal could be where, and this way you could decompose one query into 5 different ones, for instance.
I see. Oh, yeah, that's pretty smart.
Sweet. Thanks again, Rob. Next talk will be given by Peter. Okay. Maybe here. Okay. Maybe here. Over there. Ah, okay. Okay, thank you.
Okay, so hello everybody. I'm Peter Zsoldos, and I realized that I'm the only thing between you and lunch, so I will wrap it up quickly. So I'm presenting right now my work titled Text-to-SQL Framework for STSsci Server Database. This is a work that I have done with my supervisor Vera Könyves at Hunrendstaki in Hungary. And basically this will be a natural language interface for SDSS. We can just skip over agenda. We are in a short schedule. So I think everybody here knows what SDSS basically is, but just to make sure, it's a really big database about astronomical data. It has over 900 million celestial objects, and also very important attributes about them, like redshifts and images. And it's public for everybody, for educators and for students also. But there's a catch, because you have to know how to write efficient and correct SQL queries. And I don't know how many of you like to write efficient and correct SQL queries. I don't, so I jumped into this project. So basically what I wanted to do is use a RAG solution to supercharge an LLM so it can query this database efficiently, and we can somehow democratize the access to the database. So my architecture is basically this. It is very simple. The user just asks a question from the LLM. It also receives information from the knowledge base. The knowledge base here is the RAG. It just stores views and functions of the database. So the LLM actually knows how to ask the database about our question. And then it just sends the query to the SDSS, and the data that comes back is also processed by the LLM. So the user doesn't just get back data, but some summarization from the LLM also. So I've tested this architecture on many different models. Each model was chosen because it had something different from the other, so we can get some good view on what is efficient here, what is not. And also I used different hyperparameters. I checked if we really need the RAG or not, and also temperature, top P, the usual stuff. But I measured how correct the architecture is with passset1 and bleu, and passset1 just measures how was the query correct or not. It's a very hard evaluator, but bleu is a soft evaluator. It measures how similar the generated query was to the ground truth. And what I have found is that with and without the RAG, there was almost no difference regarding blue. The generated query was always very similar to the ground truth query, or to the query without the reg. But when I measured if it was actually correct, there was a very big difference. So the generated queries were most of the time not correct without the reg. So this underlines why we need it. And we have to look out that the small differences is where the whole thing is really decided. And so some other interesting things is that the smaller models had much higher increase in the accuracy, and also that large reasoning models had a very high number of queries that were their syntax was correct, but the answer that they got was incorrect. So they understood how to do the whole, they understood the database schema, but they did not understand the astronomical question. And just to wrap everything up, in the future I would like to go further with this and shift everything into a more agentic view. And I have already done this partly. You can check it out on this QR code. It will be correct half the time, and please do not do it all at the same time, because I'm already have been 10 times banned by SDSS for DDoSing them. So thank you for your attention.
Thanks a lot, Peter. Very nice talk. Okay. Yes, we have a question by Eric.
Yeah, I thought that last thing you said about how it got the answer wrong, but the syntax correct was interesting. Could you tell from following the reasoning chain what it was doing wrong? It would act would it actually self-correct itself to the wrong astronomical answer, or is it a bunch of different things that it's not easy to summarize?
I have been only going through some examples, so I can only give a vague answer about this, but mostly it was going through the schema again and again, the views and the functions, and to the end it forgot the whole context of the question. So yeah, that was the problem on the queries that I actually checked.
And maybe one more quick question. Please go ahead.
Perhaps I missed it. How do you protect yourself from queries that are dangerous for the database?
The SDSS protect themselves from this kind of queries.
You're relying on SDSS providing the protection, is it? Okay.
Yeah, I was relying on if I send them drop tables all, then they actually won't. But I haven't checked, and fortunately I don't think that it's in the training data. I hope.
Fair enough. For that. Okay, thanks again, Peter.
Thank you very much.
Michelle has some logistical announcements for us.
All I have are logistical announcements. That's all I do. Logistical announcements. Okay, folks. The next couple of hours, here's what it's going to look like. All right. We are going to do a group photo. Then we are going to lunch. Remember, both sides of the buffet. Then we are moving into our hack groups. Then we have coffee and a poster session. And you all are responsible for getting yourself to all of those places. We won't be shepherding folks between those things. It's a lot of free form time. We will be returning here at 3:30. So that's the next place, the next time that you need to be in a specific place at a specific time. So here at 3:30. For the group photo, we were going to be outside, then it was raining, then we were going to be inside. And I just confirmed with Shemaya that the weather is playing nicely. So we're going to be outside. So we're headed to the front stairs, tall folks in the back, shorter folks in the front. Stand close together so we can fit everybody, and angle yourselves a little bit toward the center so that we can kind of, you know, get nice and close so everyone can fit in the photo. Head out to the stairs, please.